Hi, as Sean said, my name is Jim Eschter. I was very fortunate to be part of the team that developed the Flywire concept that you're about to see. And I wanted to take a few minutes just to go into some detail so you have a better understanding of what our thinking was behind this concept. Now, when we're developing a product for an athlete in motion, something that dynamic, these two words are everything. The better I do my job at this, the better the athlete's going to do with the product. That's simple. And to give you an example of design efficiency, I'm going to take you completely out of footwear for a minute to something that I think illustrates an analogy quite well about what design efficiency really means. Something we can all relate to. We're going to go to bridges. Now, probably in the first centuries, stone was the most popular medium of choice. There were some spectacular arches made with this stuff, but it's very heavy. It doesn't work very well in tensile. In other words, it compresses very well, but it doesn't pull very well. It pulls apart. And when you're crossing something like a river in the picture here, there's a limit to how far an arch you can make. Yes, they've made arches longer than this, but generally you have to do several arches because the weight-to-span ratio isn't so great to get across a span. So in the 1850s, I think in England, the iron bridges started to come along, and suddenly steel enters the picture. And suddenly you can do a span which would only be in the dream of somebody who's designing a stone. I look at this slide and I often think that a lot of ways this may be where footwear is today in terms of we're using modern materials, nylons, polyesters. But are we maximizing the efficiency of the design? Are we maximizing the use of the materials? For instance, if I take the steel that's in the bridge in the picture behind me and I draw that into filaments and wind it into cables, you get something breathtaking. We as adults look at this and understand intellectually what's going on with this product. We can rationalize how it works. A child looking at this probably wonders how it holds itself up, let alone all the trucks and cars and hundreds of people that drive across it every day. It's breathtaking, and once you're at this level, you are at the extreme of design efficiency. This is where we want to be. We want to be at that hairy edge of not believable. Now, take a look at some historical shoes across Nike, innovations which have built this brand into what it is today. There's some older shoes in the case over here I saw when I walked in. Back into the Nike waffle trainer of the first generation. All of these shoes bear a very similar trait between them. They are all built of what I call a panelized construction. You take a roll of material of different properties and you cut out a panel of that, and you either layer it on top of another or you stitch it side by side, and you have the shoe that's behind me here. It's an additive process. You're building in layers. So when you want to build something that's lighter, it's subtractive. And this model doesn't work very well for subtractive. I'll show you a very interesting shoe. This was the Michael Johnson Gold shoe, very famous shoe for Nike. And I'll tell you a little story behind this. We used this first in the '96 games in Atlanta and then into Sydney. Well, this shoe was probably, I think it is the lightest track shoe that was ever done in the industry, by far. The shoe was also at its threshold of holding together. It also was a shoe that only a few athletes in the world, Michael Johnson being one of them, could run in because it was so unstructured. And we never were able to sell this shoe commercially. In other words, that was the extent we felt we could get to using the paradigm I've just talked about in construction. This is a conceptual model we hammered together in the kitchen. We took pins and hammered it into a last, and really, this wasn't about designing the visual, it was more about designing a function that we dreamed of. The function we dreamed of was putting lines of support, lines of reinforcement where we needed it and only where we needed it. We're talking about more like a string sandal, not worrying about what its construction is the rest. This is, at its fundamental core, what we'd like to have gotten to. It reminds me of sort of a string art from the 70s. Now, that shoe sat in a drawer for 2.5 years until one time we were playing around back in our own sample room on a computer stitcher, and next to it was an embroidery machine. Now, most of you know embroidery machines. If you've worn any Nike product that has the embroidered swoosh or the golf hats that have the swooshes on it, even monogrammed towels at home from Pottery Barn, they've got the swoosh in this, or I hope, the monograms embroidered in them. It's an appearance. It's simply a cosmetic tool. But what we realized when we looked at this tool is it's a wonderful printer of stitches. And if it's a printer of stitches, gosh, I mean, maybe it could print stitches in any direction. And so we started to play around with it. We actually kind of broke it. We actually did something that the machine doesn't like to do. They say very explicitly in instructions, no stitches greater than 10 millimeters. So, of course, we didn't listen to that. We changed it. We found in the back of the software something that allowed it to go further than that. We're up to about 150 millimeters in some instances today. Why am I interested in this jump? Why don't I just stitch? Well, if I stitch, I'm going like this through a textile. And when I pull either end of that, it's a spring. I don't want that. When I pull, I want that to be in tension immediately. So we wanted this to jump. We wanted to anchor it at one point, jump to from point A to point B, and complete the jump. This is the very first panel we stitched on the screen here. Sorry, up there. Slowly we get better at it. And this is the first prototype that we ever made. Some of you might see the similarity between this and the pin shoe I showed you a minute ago. Now, this is all an embroidery thread. It's a long road to making a commercial product. We're getting better at this. We spent a whole year focusing on fibers. Fibers could actually support human weight and the dynamics of a foot strike. Very huge amounts of forces coming down on that. And so we started playing with fibers that had never been used in embroidery machines before. We played with Kevlars, and we tried carbon fiber one time, Twarons. We tried everything. As a matter of fact, I think that we tore pretty much every needle out of the machine, and at one point wrapped Kevlar so tightly around it, I didn't think we were going to get it off. And eventually made this prototype, which is the first runnable prototype.